This is exercise number 10, and for my exercise today, I ran a little over a mile with a pace of 8 minutes and 45 seconds. And what was happening during this exercise is I was primarily in the glycolytic system, and so food nutrients, like carbohydrates that came out of the food that I ate today, went through glycolysis, and then we ended up with 2-pyruvate and a net production of 2 ATP. And the 2-pyruvate have 2 fates, and so the pyruvate can either be converted into lactate and hydrogen or can go through the Krebs cycle, and then eventually you go to the electron transport chain and you get ATP from NADH, FADH, and GTP. And that ATP is used in the sodium-potassium pump whenever in my neurons. So there's dendrites that receive the signal. So whenever I was running and my body needed to contract muscles or relax certain muscles in order to sustain that exercise, sensory neuron, or the afferent neurons, were taking in that sensory information, and it was being processed in my central nervous system and then sent back out through my efferent neurons and telling my muscle to either contract, relax, or no change happened. And so that efferent neuron, once it reached the neuron that's right next to the muscle cell, the signal was received in the dendrites and then integrated in the cell body, and then down that axon you get depolarization and repolarization happening over and over again. And in that depolarization and repolarization, you have the sodium and potassium pumps, and so your cells are at a resting membrane potential of -70 millivolts. And then in depolarization, you get a trickle in the beginning of sodium, and then once you hit that threshold of -55 millivolts, then sodium rushes in, and then you reach an action potential, and then repolarization happens. So the sodium gates close, potassium gates flood open, and then you get the refractory period, which is where the sodium potassium pumps come into play, and you get a influx of 2 potassium and then 3 sodium leave the cell in order to bring the cell back to resting membrane potential of -70 millivolts so that more signals can be propagated. And so after that signal travels down the axon, it hits the axon terminal. That signal can either be released in neurotransmitters that cause my muscle cells to cause contraction, EPSPs, IPSPs, or no change happens. And in my motor units, in order to sustain that exercise, my motor units either needed to acquire more motor fibers, or increase the frequency of that stimuli, or require more motor units to come into play in order to sustain that exercise that I was doing.